Hello and welcome to ashford.com. You are watching an interesting video on laser optical tweezers, how the parasite interacts with red blood cells during this short time interval. Please read this disclaimer carefully. One of the features of the malaria parasite that makes it difficult to study is the fact it takes less than 1 minute for it to travel from one red blood cell to infect another, and it quickly loses its infective ability within 2 or 3 minutes of leaving a blood cell. Now, with the help of a new device, laser optical tweezers, scientists find they can look in great detail at how the parasite interacts with red blood cells during this short time interval. Dr. Julian C. Rayner and colleagues of the Wellcome Trust's Sanger Institute, located near Cambridge in the UK, described their findings in the Biophysical Journal. Dr. Rayner, who runs a lab that is investigating the molecular details of the blood stages of the malaria-causing parasite Plasmodium falciparum, says. Dr. Rayner, who runs a lab that is investigating the molecular details of the blood stages of the malaria-causing parasite Plasmodium falciparum, says. Using laser tweezers to study red blood cell invasion gives us an unprecedented level of control over the whole process and will help us to understand this critical process at a level of detail that has not been possible before. He and his colleagues hope their findings, which reveal some surprising facts about malaria biology, will help the development of drugs and vaccines against a disease that infects millions of people and causes over 600,000 deaths a year. Laser optical tweezers exert extremely small forces using a highly focused laser beam. This allows for precise control over the movement of individual cells, say the researchers. In their study, they describe how they use the laser tweezers to pick up individual parasites as they emerge from red blood cells and deliver them to another red blood cell, showing that the technique can be used in the detailed study of the invasion process. The team was also able to use the laser tweezers to measure how strongly, and the means by which, the parasite stick to red blood cells. Parasite sticks to red blood cells by means of many weak interactions. They found the parasites are able to adhere to red blood cells by means of lots of weak interactions, which could perhaps serve as targets for new drugs that sever or block these interactions. When the parasite has lost its ability to invade a red blood cell, it retains the ability to cause temporary dents in the membranes of red blood cells. They also discovered that even when the parasite has lost its ability to invade a red blood cell, at this stage in its life cycle it is called a parasite, it retains the ability to stick to red blood cells by means of the weak interactions and cause temporary dents in the membranes of red blood cells. In a further stage of the study, the researchers used the laser tweezers to study the effect of 3 different drugs on the weak interactions. They conclude that, taken together, the findings show the power of optical tweezers technologies in unraveling the blood stage biology of malaria, at the level of individual cells. The team now plans to use the laser tweezers to find out which genes and proteins are involved in each step of the invasion process. This will allow us to design better inhibitors or vaccines that block invasion by targeting multiple steps at the same time, says Dr. Rayner. Meanwhile, a study where scientists discovered a possible way to trap the malaria parasite in a prison of its own making. The discovery also identifies a protein that offers a new drug target. Notes and references. Thank you for watching this interesting video. This channel offers motivational, inspirational, valuable and informative videos to soothe, cleanse and inspire your health, mind, body and spirit. Subscribe this channel, to find lot of interesting videos on wide range of topics here. Stay tuned and keep watching.